Q5274, which is true regarding variometer. A. An electric variometer does not utilize outside air static pressure lines. B. One of the advantages of the pellet variometer over the vane variometer is that dirt, moisture, or static electricity will not affect its operation. C. A total energy system senses airspeed changes and tends to cancel out the resulting variometer climb or dive indications. The correct answer is C. In order to wipe out erroneous indications of climbs or descents, a total energy variometer has been calibrated so that it only reacts to changes in total energy. 5275, which is true concerning variometer with total energy systems. These instruments: A. Sense airspeed changes and tend to cancel resulting climb and dive indications. B. Will consistently register climbs that result from stick thermals. C. React to air mass climbs and descents like a conventional rate of climb indicator. The correct answer is A. Variometer with total energy systems incorporate airspeed information to compensate for changes in airspeed that may affect the variometer indications. These instruments sense the changes in airspeed and use this information to adjust the variometer indications, aiming to cancel out the climb or dive indications that may result solely from changes in airspeed without changes in altitude. 5297. The advantage of a total energy compensator is that this system: A. Includes a speed ring around the rim of the variometer. B. Adds the effect of stick thermals to the total energy produced by thermals. C. Reduces climbs and dive errors on variometer indications caused by airspeed changes. The correct answer is C. The advantage of a total energy compensator in a variometer system is that it reduces errors in climb and dive indications that may be caused by changes in airspeed. Total energy compensators take into account the changes in airspeed and adjust the variometer indications accordingly, aiming to provide a more accurate indication of the aircraft's vertical movement regardless of changes in airspeed. This helps pilots maintain better awareness of their actual climb or descent rates. 5612. In the Northern Hemisphere, if a sailplane is accelerated or decelerated, the magnetic compass will normally indicate: A. Correctly, only when on a north or south heading. B. A turn toward south while accelerating on a west heading. C. A turn toward north while decelerating on an east heading. The correct answer is A. The magnetic compass will normally indicate correctly only when on a north or south heading. Is true is because of the phenomenon known as acceleration and deceleration errors in magnetic compasses. Magnetic compasses are affected by the Earth's magnetic field, which is inclined towards the north magnetic pole. When an aircraft is accelerated or decelerated, the compass needle is subjected to horizontal acceleration forces that can cause it to deviate from its correct heading. In the Northern Hemisphere, when a sailplane is accelerated or decelerated on an east or west heading, the compass needle will experience these acceleration forces, leading to errors in its indication. Specifically, during acceleration on a west heading, the compass needle tends to lag behind and may temporarily indicate a turn towards the south. Similarly, during deceleration on an east heading, the compass needle may temporarily indicate a turn towards the north. To obtain accurate readings on a magnetic compass, the sailplane should be on a steady north or south heading where the acceleration or deceleration forces do not affect the compass needle. This allows for a more reliable indication of the sailplane's actual heading. 5613. When flying on a heading of west from one thermal to the next, the airspeed is increased to this speed to fly, with the wings level. What will the conventional magnetic compass indicate while the airspeed is increasing? A. A turn toward the south. B. A turn toward the north. C. Straight flight on a heading of 270 degrees. The correct answer is B. In the Northern Hemisphere, When an aircraft accelerates or decelerates on a west heading, the compass needle tends to lag behind the actual heading and momentarily indicates a turn toward the north. This is known as an acceleration error. When the airspeed is increased to the speed to fly, while flying on a west heading, the sailplane experiences acceleration forces. These forces cause the compass needle to temporarily deviate from its correct indication and turn toward the north. Therefore, while the airspeed is increasing on a west heading, the conventional magnetic compass will indicate a turn toward the north. It is important for pilots to be aware of this compass error and rely on other instruments, such as the heading indicator or GPS, for accurate heading information during periods of acceleration or deceleration.